Cast is now starting. All attendees are in listen-only mode.
What an exciting day. Well, good morning, good afternoon, good evening, wherever you are in the world. Welcome to the DB2 Night Show. This is episode number 213. I'm your host, Scott Hayes, an independent entrepreneur, IBM Gold Consultant, and lifetime IBM champion. Today, our special guest is none other than Paul Bird from the IBM Toronto Lab. He's a senior technical staff member, and we're going to talk about Db2 LUW Native Encryption. Paul, how are you today?
I'm good, Scott. Thanks for inviting me.
Well, it's a real treat to have you on our show again. And you've got an important topic for us today. What with all the data shenanigans going on in the world, and talk about encryption. So let's move along here. DB2 Night Show is a show for the community. Hopefully you're following us on Twitter. If you do any tweeting, we'd like you to use the hashtag #DB2Night. Also in those tweets, mention at DB2 Night Show and IBM Paul Bird. That's a great way to get a hold of your guest speaker today. And we have a LinkedIn group for you. If you'd like to join that, just go to bit.ly.join-DB2Night-Show. And in that group, we talk about upcoming shows and things that you like talking about, all things DB2. Oh, the show disclaimers, we just put this up here for a moment. The net of it is no liability, all risk, views are materialized in your own mind, and trademarks belong to the people that they belong to, and we're recording, and that's enough of that. You can read it if you like. Next, tonight's show, we're going to do a few quick announcements. We're going to have Paul's fabulous presentation. At the midpoint, he'll take a break, and we'll ask some studio audience polling questions. We'll have a little commercial from today's show sponsor, DBI Software. We'll complete Paul's presentation, and then we'll wrap up. That's the flow of how we go. All right, here's an opportunity for you. DBI Software is doing things differently these days. They've got an on-demand demo opportunity for you to participate in. Just go to the demo tab on DBI's site, and you can watch an on-demand recorded demonstration and earn yourselves a $15 Amazon gift card just for watching that demonstration. So there's the URL, dbisoftware.com/demo.php. Some upcoming shows on the 12th of April. We've got All About iDoug coming up. That's our annual show about iDoug. And during that show, we will announce the winners of the free iDoug badge for people from people that have participated in the state of the DB2 Universe Study. And we'll be giving away those Amazon gift cards too. So try to get yourselves in that show. On the 24th of May, breaking news from the IBM Toronto Lab. They've got big news to share. You don't want to miss that. And on the 21st of June, that's our season number 10 grand finale. We're going to have a 3-hour problem determination class with Pavel Schuster. You might recall he was our guest back in January giving us some problem determination tips. This is a 3-hour class. What a way to end the season. On the mainframe side of the house, 26th of April, DB2 ZOS, latest news and future directions with Jeff Jostin, IBM. And you know, he's a great speaker. So get yourselves over to db2nightshow.com, get registered for those upcoming shows. Congratulations to Mr. Kevin Gardner with Honda Manufacturing in Lincoln, Alabama. He's a winner of a $25 Amazon gift certificate. He completed the survey after our prior show, and his name came out of our lucky hat. He's going to win that gift card. He was in show number 212 with DB2 LUW SQL tuning. Klaus Bronf was our guest. Speaking of the state of the DB2 Universe Study, I hope that you've participated. We've got a few hundred participants already. That survey is going to close on April 1st, and that's not an April Fool's joke. That's your last chance to participate. We're trying to learn, what are DB2 usage trends? Is DB2 growing? What are DB2's most popular features? What are the most popular tools? What skills are needed? Can the IBM labs improve DB2, and how so? What technical education should IDUG provide? Participants can win an IDUG badge or one of several Amazon gift cards. You can get there by just going to bit.ly/DB2 Study. And that is a big D, little b, the number 2, a big S, TUDY. bit.ly/DB2 Study. Make sure you participated in that. That's how you're going to find out the survey results, by participating. And then you can know if your skills are in alignment with DB2's top features. And incidentally, ladies and gentlemen, our guest today, Paul Bird, was a significant contributor of questions in this study. So you really be helping the IBM Toronto Lab out if you can participate in that. A little giggle for you to start your day. Found this cat picture. You know, we're obsessed with cat pictures these days on the interweb. And this says, "Oh, hey, you're home early." Little cat removing the toilet paper. What fun. Okay. Paul, do you have a cat?
Used to, not anymore. Dogs.
Dogs now.
Dogs are the thing now. Yeah.
Well, so far, I have been looking in at the DB2 study periodically, and there is just one fun question there about dogs and cats and birds and other pets and things. And so far, the study is going to the dogs. The DB2 people tend to like dogs best. All right, let's make you our presenter and get you going, Paul. I'm going to click a little button over here and say Make Presenter, and you'll get a little pop-up on your side that says Show Your Screen, and hopefully we'll be able to see your screen. We've done this before. Hopefully no troubles today. There we go. I see, there you are. You're in presentation mode. DB2 Native
See everything?
Can see everything in full screen mode. It looks beautiful.
Excellent. I'm just closing all these windows so that I can actually see it.
That's always a good idea. And shut down your instant messengers and email, and that way, you know, we don't get interruptions from your girlfriends and things.
Yeah, don't tell my wife. So, okay, here we go.
Here we go.
Wait, jump back out. All right. Thank you, Scott. For those who don't know me, I'm Paul Bird. I'm a senior architect here in the DB2 development group. I've been here since the beginning, actually, with a little short vacation for a couple of years. So what's that, 28 years now, something like that?
That's a long time.
It feels like it. So today's topic is about DB2 Native Encryption, and it's specifically, it's coming from a blog I did a while back. I have an IDUG blog in case you watch it occasionally. And I got a lot of people either not asking the right questions before they jumped into encryption, or people sort of discovering things just before they went into production. So I wrote some things about what to expect when you're expecting to encrypt. And so what I'd like to do today is give you a brief overview of encryption. I don't know where everyone's starting from, so I'll give an overview. And then briefly talk about the considerations you should have for performance, which is the #1 question. And then availability and operational considerations that aren't always thought about. So I raise them here because you do need to think about them. They're not just pertinent to DB2 encryption, they're pertinent to encryption of data at any time when you're storing it on disk. So let's go through it and see what we discover. So what is DB2 Native Encryption? So this is actually an encryption progress that's integrated into DB2, and it's put there to allow you to protect the most critical database files. It's using FIPS certified, which is the U.S. government sort of standard for this is good. FIPS certified algorithms in order to provide the encryption mechanism. It encrypts the critical database information such as your system and user-defined data, your transaction logs, your backup images, load working data, both the copy data and the staging files. So it's covering the sort of the data you want to protect. And then why would you be interested? Well, the number one reason for encrypting the data is typically for offline threats. So people not actually connected and working in your database, but people have access to the file system, or people who are able to get to where your backup logs are stored. So it's theft or loss of media, and you're trying to protect against that threat. The other reason to look at DB2 Native Encryption in particular is you want to protect the data wherever it exists. So, for example, if you're using a file system for encryption, when you write the data to that file system, it's protected. If you then copy the data to another file system, it may or may not be protected depending on whether that other file system is encrypted. So when you do things like backup, you have to actually encrypt the data that's in the backup, because you might then port that around to different file systems or different, whatever your backup mechanism is. So you want to protect the data wherever it goes. And so DB2 Native Encryption provides that. And the final reason you might be interested, of course, is as of 11.1, it's free on all our offerings. So it's not an added cost, it's there, you can use it.
And free is a very good price.
Yeah, a lot of people like free. But as you know, Scott, there's no such thing as a free lunch in the real world.
That's
so
right.
The costs here are not what you pay IBM, but it's what you have to take on when you take on encryption. So that's what this presentation is about. This picture is just to give you an example of, in case people learn in different modes. So this is more showing you that the actual the cylinders that are shown there, those are the DB2 files that are being written, and they're encrypted. But the file system itself is not. So it's just showing that we're actually, as we read and write, we're encrypting the data we write to disk. And there's one cylinder there that's not encrypted. It's just showing that not everything is encrypted. So if you export data, it's not encrypted by DB2. So it's just another way of looking at the same information. A couple other key highlights I'd like to hit. Very simple to deploy. You just basically create the database as encrypted, and you're working with it. The applications don't have to change, so there's no application or schema change required. We support all our platforms and configurations. We're available on all of them. And if there's CPU hardware acceleration that's applicable, we will automatically detect and use it. So there's the Intel hardware acceleration with the new instruction set. Power 8 and Power 9 both have in-core support. What do they call it? Advanced Encryption Standard. I think they call it AF. I can't remember their acronym. And also on Z, on Linux on Z, we use their CPAC.
Very nice.
So that becomes critical later on. We'll get back to performance when we talk about that. How does it work? It's pretty straightforward. It follows the industry standard approach where you actually have a data encryption key, which we refer to as DEK. That's what's actually used to encrypt the data. That's the magic key. But that itself is protected. That's not kept in the clear. That's protected by a master key. And the master key is not kept in the same place. It's kept outside of DB2. So the master key is used to encrypt the data encryption key, and the master key itself is stored in an external key store. So the two keys are not together, and they're never in the clear. And the basic idea is that, sorry, go ahead.
There's a key to get to the key.
Well, actually there is, yes. You need a key to get to the key store. So there's always a key, Scott.
Okay.
The basic idea is whenever you read or write data to disk, the data encryption key is used to encrypt or decrypt the data. And whenever you need to access the DEK in order to do those actions, you actually have to go and access the master key. So you get the master key, you decrypt the data encryption key, and now you can decrypt the data. That's what DB2 is doing under the covers. There's a few acronyms up ahead, and rather than explain them all the time, I put one slide here right up front. OASIS is the Organization for Advancements of Structured Informational Standards. Basically, this is the group that sets up the standards for security, and they've published a couple of things that are being used. PKCS, Public Key Cryptography Standards. This is the older standard that's been around for a while. There's actually two parts to it, 11 and 12, that are used a lot. 12 refers to how to create a secure file, so Keystore files. It's sort of a password encrypted file. And PKCS11 is more about a protocol for exchanging and communicating cryptographic tokens between two entities. Finally, the newer protocol is KMIP, Key Management Key Management Interoperability Protocol, KMIP, and this is actually a newer, more modernized version of the protocol for exchanging keys in a key management network. So I'll be saying KMIP and PKCS11 and 12 a lot. Come back to this slide if you forget what they mean, but they're basically standards.
What will we do without acronyms?
Well, I work for IBM, so I have no comment. We live for them. In terms of the Keystore, so I mentioned the data encryption key is kept inside DB2, it's encrypted. The master key is kept outside. We support 3 options as of 11.1. In 10.5, we supported the local Keystore file, which is that PKCS12 standard. It's just a local flat file that is protected, and then DB2 can access it. Starting in 11.1 GA, we supported the KMIP 1.1 protocol. Basically, any KMIP version 1.2 and above will support 1.1. And that is the newer protocol, and we supported that to talk to a sort of a centralized key manager. And then we later, as Mod 1, we introduced PKCS11 support, which is what a lot of existing customers have out there with their hardware security module, the HSMs. They have products out there already in use in their enterprise, and it uses PKCS11. So as of 11.1 modification 1 or fixpack 1, depending on your preference, we support the 3 key mechanisms used to protect external keys. So this is just in English now, same thing. For the hardware secure modules, so for KMIP 1.1, we support any product that claims to support KMIP 1.1 or higher. For the hardware security model, the PKCS11, that protocol is I may use politically incorrect, but it's a bit more flaky and a bit more dependent on the vendor's implementation. So that one we actually had to test specific vendors. And so we've tested 2, which are the 2 most popular ones. In fact, now I think Thales has bought out Gemalto, so there's all kinds of things going on in the industry. But Gemalto, which formerly was known as SafeNet, has an HSM, also known as Luna. Well, we support 6.1 or above, and Thales Enshield we support as of their software level, 11.5 and above. So if you're not sure if your HSM or module you have is supported, feel free to ask and we'll give you an answer. A couple other little points here. A lot of people have HADR where you have a standby running, and so the question often comes up is, well, I want to encrypt. Do I have to encrypt both? And the answer is yes. You have to encrypt both, and they have to use the same master key in both. They can each have their own unique data encryption key, but you want the same master key because there can be transition points, and you need to be able to, the data is shared between the 2. Sorry, not the data, but the log files are shipped between the 2. So you'll send across a log file that needs to be decrypted. Anyways, so the primary standby both require access to a Keystore that has the same set of master keys. It doesn't have to be the same Keystore. If you want redundancy, you can have 2 Keystores, but they have to have the same keys. If the standby does not have access to the master key, it will shut down. And you're going to hear that a fair bit throughout encrypted database. If you can't get to the key, you will shut down. And we just had a customer who lost their Keystore and asked us if we could get access to their data, and the answer was no. That's why you encrypt it, so that we can't. Fortunately, it was a development system, so it's not the end of the world. It was a development system. So yeah, our hearts stopped there because we've been waiting for someone to come and say, you know, my production system is down. Come and decrypt it. Anyways, that's the biggest lesson. If you take anything away from this, is like this is a you have to have processes in place to protect yourself from this. And you hear this over and over again.
How many characters is the key?
I think the standard is 256. That you can use smaller or less, but that's the recommended, and there's reasons for that. And you'll hear about quantum cryptography and so on. I can talk about that at the end, but there's a certain I'm trying to remember whether it's 128 or 256. There's a certain sort of minimum standard expected.
I was just wondering if it was, within the realm of what I could memorize.
No, this is not something you memorize, Scott. This is not. Windows just went to 16. Our protocols just went to a 16-character password for our Windows boxes, and I can't remember them. So 16 seems to be the human limit.
Okay.
Okay. The other thing about HADR is that right now, when the master key is rotated, I'll talk about that in a bit. It's not currently logged and transmitted independently of data. So you can rotate the key. This is the key that's used to protect the data encryption key. So you can change that. And when you change it, it changes on the primary. It is not sent to the standby until some data from transaction or whatever is sent to standby. And at that time, the standby will then rotate the master key. There's an RFE to enhance that if anyone wants to vote for it. But right now, it's not independent. And finally, I can't remember my slides now. When you're talking about a multi-member system, DPF for PureScale, so the same data encryption key is used on all the members. Obviously, it makes sense in PureScale because they're all accessing the same data, and the master key for the same reason. They all require access to the Keystore. So for some vendors, depending on their licensing model, they may say, hey, you can have 100 connections to the Keystore, that's fine. And others may say, for every 10, you have to have a new license. So if you have a 20-member system and you're using the second vendor, you might have to have 2 licenses, that type of approach. So be aware of licensing impact. Ideally, you would use the same Keystore for all the members, but you don't have to. You could have, each member could have its own Keystore, it just makes your life more difficult when you rotate and change master keys. But you can do that. It's just, it's a single point of failure. We'll talk about that in availability. I'm just trying to get through the overview. Deploying, so today, in order to deploy an existing database, you actually have to recreate and reload the database. There's definitely an RFE for this. Please go vote for it if this is annoying to you. It's annoying to me, so I'm asking for your support. But basically, you recreate and reload the database or restore from backup into an encrypted database. You can also leverage the HADR relationship. I'm not going to go into details, but basically, you create the standby as encrypted, and then you catch up to the primary, and then you fail over to the standby while you encrypt the primary. So you basically take advantage of the fact you have 2 copies. There's lots of details. The native encryption documentation was rewritten in modification 3 or 4. It was, to be honest, it was pathetic before that, so I rewrote it. There's a lot more details. In fact, a lot of this information is now in our documentation. So if you go to the latest Db2 Native Encryption documentation, there's a lot more detail there.
Well, thank you for saving us from the documentation inadequacies.
Well, it's when someone asks you a question, you go and look at it and think, oh, this is bad. And I don't want to blame the documentation people because it's not their fault, but it just, it wasn't up to the standards needed for something new like this.
All right.
All right. Let's go on to performance considerations. Scott, you just give me 5 minutes warning when you're before the halftime, okay? And I'll find a place to wrap up.
Maybe after you do the performance considerations and get into the next topic, that's when we can do our little break.
Okay. All right. Well, performance considerations. This is, as I said, this is the #1 question everyone comes and asks about, and they all worry about it. Obviously, because if it impacts your workloads, then you're going to hear from your end users and your customers, so you don't want to do that. So this is how my hand-waving approach to explaining how DB2 native encryption affects performance. So think of it this way: DB2 encryption, decrypt and encrypt, is happening every time there's a physical I/O to a disk. So every time we read or write to a disk, we're doing some work. Now that work is currently, depending on your system, it's at least going to be software running. And so the net effect is that there's overhead in your bandwidth. And when you do encryption, decryption, it actually shrinks your I/O bandwidth. So the net effect is similar to replacing your current disk set with a slower disk set or a smaller bandwidth. That's the way you should probably think of it as a first level conceptual, impact of performance. So the impact on your workload depends completely on whether you care about physical I/O. So if you're completely protected from the buffer pool and you're just accessing, you have a 1,000% hit rate in the buffer pool, then it may not affect you at all. I say may because if your background buffer pool access, like prefetchers and what have you, are able to keep up, then you won't be affected. If they suddenly can't keep up, then you would be affected. So the answer is primarily depends on about how much it affects you is based on physical I/O. How much overhead there is on the physical I/O really depends on whether or not you have hardware acceleration. And this is the biggest factor because it can reduce the overhead from 10, 20, 30% down to 5, 6, 8%. So a significant reduction in the overhead. So it really determines the size of issue you have to deal with. The easiest way to find out if you have eligible hardware is to check your DB2 dialog when you type DB2 start. We automatically, as of 11.1, we're actually 10.5 fixpack 5. We're looking to see if that's available, and we will put out a little dialog message. So it'll be something like this, right at the beginning after DB2 start. There'll be this cryptography context real init dialog entry, and it'll have a little data number 3 should have a little message saying it's available or not available. And that will tell you whether or not your existing hardware has it. So I can tell you, for example, Power 7 does not have it. So Power 8 and Power 9 does. Many Intel boxes do. There's a website where they list everything that supports their AES-NI, the new instruction set. But this is the quickest way. You can go look at your current systems and see what shows up for that entry. All right, so go back to how it actually affects your workload. So as I mentioned, it all depends on how sensitive your system is to increased latency on your physical I/O. So obviously, any work that's doing I/O, a lot of I/O, like backups and ETL, will be hit the hardest because there's a lot of physical I/O going on. So there are a number of factors involved. The amount and speed of the CPU that's available for encryption, decryption. This encryption, decryption is done by the process that's actually doing the read and write. So if you can get a CPU and it's pounding away, that's great. If you have one CPU that's shared by everyone, it's going to be doing time slicing and it's going to take longer. The amount of buffer pool used, I mentioned that earlier. The ability of the background process to keep up. That's what I was alluding to earlier. So if right now you're completely buffered and everything's good, but your buffer pool processes, the page fetchers, the page cleaners, are just keeping ahead of your workload. Well, now maybe after applying encryption, they don't keep up, and now you start getting physical I/O occurring or I/O waits occurring for your user workload. The amount of non-buffer pool I/O, so anything that's not cached or protected, such as LUW, direct reads and writes, they're going to be directly impacted. And then the amount of parallelism, how many different processor agents, I say processes, I don't mean operating system processes, I mean entities that are trying to do the work. How many of them are actually trying to do reads and writes? Is it all going through one, or is it being spread across multiple? Obviously, if it's going through one, you're going to get serialized. If it's going through multiple and they have their own CPU, then you get parallelism. Well, I gave a hint. How bad can it get? So it can be orders of magnitude slower. It can be, and backup in particular is affected, and I'll get onto that later. So here's an example from a Power 7, which has no hardware acceleration. So when we set up backup, or we started running it using just a single process, it was 5 times degradation. It was being serialized, and there was no hardware encryption on that system. Because this had, this is key thing here, because that particular backup had multiple table spaces, we were able to leverage backup parallelism and reduce the overhead to just 30% by suddenly using parallelism. So it's just meant to give you an example of the worst case, and also how parallelism can help improve it dramatically.
Okay.
So what I recommend doing, and I think it's a good way to approach it, is that when you encrypt a system, instead of saying, oh, I've got my existing tuned system and I'm just going to encrypt it and keep running the way it is, start by the assumption that I've just replaced all my disk systems and with slower disks. And so I need to actually sort of start from the beginning, start tuning and look for I/O bottlenecks and follow. Steve Reese has a number of good presentations giving you algorithms and approaches. Basically tune your system from start as if it was a brand new system, particularly focusing on I/O. And you definitely want to look at all aspects of your workload and operations under native encryption. A lot of people just test the user workload and then are shocked and dismayed to find their ETL or their backup is tremendously slower. So visit all the areas, make sure you truly understand the impact and see what can be done, if anything, to improve the impact. If there is additional CPU available, so you have multiple CPUs and they're not all being used, or not all being used 100%, then you should increase parallelism where possible. Obviously, if your CPUs, if parallelism won't help if they're all using the same CPU. So there is a correlation here, right? You need to make sure that you're being smart about it when you introduce parallelism. You're not just adding more things to the system. I'm sure Scott would have lots of practical experience on that type of world. Now, as a late-breaking note, so to speak, if you're on AIX, now this particular slide is talking about SSL, secure communications, but it applies to native encryption as well. If you're using AIX on Power 8, Power 9 with hardware, even Power 7, the way AIX memory model works is they decided they have an old memory model and they have modern ones available, but they decided to keep the default the way it was and have users decide to change it. So I have some charts here, and basically the way to look at it, ignoring that it's for SSL, to the left of the first black line, that's the system as a applied security. So basically SSL is doing encryption of things going across communications. So imagine that this is also doing encryption of things going to disk. So there was an impact. And then they changed, the middle bar is when they changed the malloc options, as the tech note I highlight here, to use the more modern, basically allow parallelism inside the memory model. And you can see it drop significantly. And to the far right is what it's like before they applied any encryption. So I'm not saying this is what native encryption would look like, but I am saying this is what it would look like in terms of the general conceptual impact, right? If you don't change the default and you have high parallelism in terms of lots of people trying to do encrypt, decrypt at the same time, your chart or your performance impact will look like the left-hand side, whereas your original might look like the right-hand side. And in the middle, with these malloc settings, it can certainly make a big difference. So it's certainly worth looking at if you're on AIX and you're running a high degree of parallelism. Read the tech note and you can find out more. All right, Scott, that's the first section. You tell me, keep going, or do you want to run your commercial and your poll?
We'll do the next bits here on this side. Silly go to
You have to give it back?
Yeah, I'll grab it back.
Okay.
There we go. So that takes us to one of my favorite parts of the DB2Night show, is our polling questions, where we plug into the DB2 community and find out what's going on. What DB2 LUW versions are you currently running? And we'll see how the adoption of version 11 is going today, Paul. At least with today's audience, we'll see. There's so many improvements in version 11 across pure scale and the encryption here. Hopefully people are getting up and moving along and getting up to version 11. I'd like to see 80% of our audiences vote, or we give them 30 seconds, whichever comes first. Let's get a couple more clicks, going once, going twice, closing the poll, sharing the results. And version 11 is the winner at 78%, 67% have 10.5, 28% on 10.1, 39% on 9.7. That was a great release of DB2. And 11% are hanging on to the good old stuff, 9.5 or earlier. Next polling question. What operating systems do you use for your DB2? AIX, Windows, x86, Linux, Z-Linux, Linux on Power. I understand there's some others, but GoToWebinar only lets us provide 5 choices. So we pick some of the most popular ones and see what y'all think. Now, this is interesting so far. 82% have voted, so we'll go ahead and close this and share the results. What a surprise. This doesn't happen often. For the longest time, throughout the 10-year history here of the DB2Night shows, AIX was always the winner. But look at this, 83% on x86 Linux and only 56% on AIX. Wow, 33% Windows, 17% Z Linux. That's a great platform. 6% Linux on power. So x86 Linux has surpassed AIX with today's audience. Are you using DB2 Native Encryption? Yes, not yet evaluating, no. I can't say my response is encrypted. That's just funny. I provided that fourth option because somebody might construe this as a security-related question. I don't want people to know if my data is encrypted or not. Let's catch another vote. Going once, going twice. Closing the poll, sharing the results. 11% today said yes. It's all aggregate data anyways. 39% not yet, but evaluating. 44% no. 6% took the clickbait on can't say my response is encrypted. Okay, so you got a lot of evaluators out there, Paul. Good thing you updated that documentation. Another polling question. Are you using DB2 in that fluffy cloud thing? AWS cloud, IBM's cloud, another cloud, not yet. Considering in the future, no way, no how, not for us. We're not going to go to the fluffy thing. Our good-looking audience is voting.
So I assume you mean public cloud and all those, right, Scott?
Yeah. Different permutations of clouds here. I just saw some Twitter buzz about DB2 is now on the AWS cloud or something. Do you know anything about that, Paul?
Yeah, I just retweeted that. Yeah, so it's now being offered as a formal offering versus you bring it over and run an AWS. It's now there as one of the options.
Oh, how exciting!
Yes.
Okay, closing the poll, sharing the results. 11% across the board, AWS, IBM, and other cloud. 33% saying not yet, considering in the future, and 33% say nope, not us. What else do we have? Are you using PureScale? Version 11 made PureScale a lot easier to use. And after version 11 was out for a little bit, then start to see some adoption of that. And I think PureScale's been doing pretty well in this last year. Great way to improve availability. Going once, going twice, closing the poll, sharing the results. In today's audience, nobody's using it yet. 17% are thinking about it or planning for it. 83% say no need for their particular environments. And I think that's it for our polling questions today. A commercial break from today's show sponsor, DBI Software, offers smarter tools for smarter people. DBI has been recognized by Database Trends and Applications magazine 6 years in a row for trend-setting products. And did a little look around the internet and was trying to see what other tools have won industry awards and recognition, and I had trouble finding other things, but DBI is doing pretty good on the industry recognition. And some top DBI pure feet advantages. DBI has the lowest overhead that you'll find in the industry. Meaningful trend charts with history plotted on them. And you can get some pretty charts in some tools, but you need the contextual information of those historical data points plotted on the charts so that you can correlate. When I made the buffer pools bigger, my buffer pool hit ratio improved. And I have advanced index benefit analysis. That's going to show you what each of those recommended indexes are actually worth. My favorite, predictive index impact analysis. And in the newest release of DBI, version 7, there's a new workbench that lets you modify the recommendations or even create your own index to put that through the evaluation process. That's really cool and really useful. There's an extreme focus on relative weights and costs, helps you find real root cause problems in just a couple of mouse clicks. There's also very robust, extensible lights out alerting. And I was asked to let everybody know that in Q4, DBI will have its next release or version to include drop index impact analysis, and that builds on the predictive index impact analysis. The idea behind that, as I presented in some IDUG sessions, is you want to know, well, if I'm going to drop this index, how will my workload be impacted? Will I have a net overall gain in performance, or will it be cost adverse to do so? And so DBI is working on that. Look for that in Q4. And I think that's the end of the advertisement. So I'm going to find Paul and make Paul the presenter again. Click that button and you're back on the air, Paul. There he goes. We can see your screen again. And you left off at the end of performance considerations. Somehow you lost your place in your presentation.
I was so enthralled by your presentation that I got distracted. All right. So we were talking about availability. So I mentioned performance is the number one question people ask before they get into encryption, or the number one thing they test. The number two thing that they don't always test, but they sort of discover right away, or they sort of begin to worry about as they get closer, is availability. So the next section is talking about considerations for availability. I mentioned this at the beginning, but words to live by: if you can't get to the master key, you can't get to your data. So your key store is just as important as your database. The key store is where is the external thing outside of DB2 that contains your master key. So you need to plan how to keep your key store available. When DB2 is running, it occasionally needs access to the master key. And if it can't get to the master key, you can't get to your data. So what I say is key store availability issues are database available issues. So if you lose communications to your key store, your database is not available. If your key store goes down, even if the communications is up, you lose your database. So if either one of those events happens, well, you can't get to your data. So you need to plan for that. And that's just for your normal execution.
I think this deserves a sound effect. Kong. To lose your key or access to it.
Yeah. So that's, live access to it. And then if it does go down, you have to think about how to recover. The key store, the external key store, it's external. So the DB2 backups do not include the contents of the key store. So this backing up and recovering the key store and its contents is a new responsibility for you. So you have to take that into account. You could have great database backups going back 7 years. If you can't get to this key store for those backups, you can't get to the data. So it also has implications for how and when you add a new master key. So you can generate new master keys or physically add one to your key store. And then, as I mentioned earlier, you can rotate the master key. You often rotate the master key because potentially it is exposed. The master key is outside the database and might be used in other applications. So you might say, oh, it might have been exposed. Let's rotate it. Let's change it. So when you put a new master key in the key store, you have to make sure there's a backup containing new value before you go and tell the database, start using that master key. Because as you can see, if you don't do that, then the database is using the new master key. If you suddenly lose your key store and you don't have a backup of it, you've lost the new master key. You don't have the master key. Guess what? No master key, no data. The resiliency of the key store is another aspect. As I as I'm harping, if it sounds like I'm harping, I'm preaching here. You know, the content is irreplaceable. Those master keys, unless you happen to have memorized the entire
256 characters.
Yeah. You're not getting it back. And if you don't have it, you don't have access to the data. It also includes access, like credentials to access the Keystore. So password, Scott was joking, you need a key to get the Keystore, but yeah, you do. So whether it's a password or some other mechanism, the credentials to access the external Keystore are just as important as the content, because obviously you need to get in order to see them. The communications are less essential, but you need SSL and certificates to communicate in a protected way to the Keystore. So those need to be able to recover. And then for some of the Keystores, particularly the HSMs, the hardware security module, they actually, the way it works is there's actually a client library provided by the vendor that DB2 is interacting with. So that library, that software library, needs to be available. So if something happens and your system gets wiped out, you need to be able to put that library back in place in order for DB2 to start communicating with the HSM again. So there's a couple of different aspects there that need to be considered when you're talking about resiliency of your Keystore. And that's the sort of some people think about it, some don't, but the message is no master key, no data. So that Keystore and its contents are just as important as your data.
Well, that's why I like to say full employment for all DBAs. There's always more to do.
Oh, of course. Well, as you get rid of one thing, you get new work, right? So every time you say the DBA's job has changed, well, it hasn't. You still have a job. There's still other work to do. Okay. Operational considerations. This is the one that tends to not be asked before they get going, especially people who've never had experience with encryption before. So I raise it up here, and I like to talk about it just so you have a chance to think about it before you get too far into it. So introducing encryption of any type, not just DB2 Native Encryption, brings additional responsibilities to your operations. I mentioned earlier that it extends your scope, because now you have to protect and manage that external Keystore. So that's a net new addition in many cases. There are new wrinkles to your operations. So you need to be able to access the Keystore. So you have these credentials that need to be protected. It's almost like, the password to root. It's that type of, you need these credentials to protect your key, but people need that in order to start the database, etc. So you need to think about how are you going to securely handle those credentials needed to access the Keystore. As well, you need to adjust your disaster recovery strategy to account for the Keystore and all the things I mentioned earlier. So you need to look at your existing plans and say, oh, we got to add the Keystore, and where are we going to get the backup, and how will we deploy it, etc. And then finally, encryption may actually require changes to your existing operations, because it's going to impact the performance and how things work. I have some more slides on this in a second, but particularly disk compression techniques used for backup is a major impact, and the windows used for backup restore may no longer be adequate. They may not be long enough. So let's look at some of the planning aspects. So from a planning perspective, you need to be able to think about the availability and recovery of the Keystore. So this is going to depend on your configuration. So if you have a single member or multiple members, you have to think about how are they going to get to the Keystore, and if I have multiple Keystores, how am I going to back up and recover multiple Keystores? As well, each vendor may have particular offerings or particular capabilities in their product for that. So it will be vendor and configuration specific. So it will be unique to you. There may be some templates available in terms of what other people who, for example, I run DPF and I have one Keystore and I'm using Talus. I say, okay, maybe I can use your template of the type of things you're worried about. But there's not going to be just do this type of answer. You have to figure it out. Network connections. So I mentioned, you have to have access to the Keystore. So do you have just one route to the Keystore, or do you have multiple? How are you going to handle the credentials, the latency, what's the speed? We have had people encrypt databases where the Keystore is flaky. It's occasionally, they admit this, they say it's not always available. So if they happen to hit one of those times when DB2 needs the master key, they don't have access. So they've had to think of some other ways around that. And then capacity planning. I mentioned the licensing, it differs by vendor. So that's also another aspect. Both the licensing and the performance. How much, we've done some more caching, so to speak, inside DB2, so we don't need the master key as much. So as of modification 4, it's very different behavior in terms of master key access than it was in GA. So we have been making improvements and trying to reduce the number of times we need the master key. But the Keystore has to be available. It can't be something that's just available when you start the database and then you turn it off and you don't have to access it. I did mention earlier, so Gemalto and Talus. So Talus has actually bought up, I think, everyone. So there have been some changes in the vendors, and now I think they've rolled it out into a separate company. So you'll need, it's a new vendor, right? You're not buying IBM DB2 Keystore, you're buying a vendor's product. And if you don't already have it, you have whatever your process is for introducing new products and vendors, you're going to have to follow it for that vendor.
So that kind of begs the question, when does DB2 need access to the Keystore?
Well, I don't know if I have it in this deck, but basically, obviously, during startup,
right?
When it's accessing, when it's creating a backup, when it's restoring a backup, when it's first reusing a transaction log, and there's a few RFEs that might change when that happens, but right now, that's my hand wave answer. We do have a more detailed answer, but I don't think I have any slides on it here.
Okay, that's a good big picture.
So I said, you have to pick a Keystore, and you have to pick one. Well, that's your choice, and it's dependent on many things: your budget, your strategy, if you have existing products in your enterprise, your outcome. You're going to sit and evaluate, and you choose based on your criteria. The only thing I would say is that despite it being the lowest cost option, meaning free, we would strongly recommend that you don't use the PKCS12 Keystore file. Just because, first of all, you have to do everything for that file, everything. There's nothing done for you. So that's not a good thing. So we recommend a third-party product such as those offered by Talus or Gemalto to do this for that reason overall. There are also, for example, that customer I mentioned that lost their Keystore, that was a file. They actually, somehow the file system got wiped and the Keystore file was there and they had nothing. So they had to start from scratch.
Wow.
Whereas with the other products, they're separate, often they're separate hardware and they protect it themselves and they have their own backups. So there's multiple layers of, you can't really do stupid stuff to yourself easily. So the other thing the third-party products is they have flexible connection options. They're network-based versus a file system approach. And that's very useful when you're dealing with HADR multi-member configurations, when you want to share the same Keystore. And they also have talked about and defined, have practices for backup and availability requirements. This is their business, this is what they do. So that's why we'd recommend using a third-party product rather than the Keystore file, especially once you get to 11.1. There's no option in 10.5, but once you move forward, that's what we recommend. Keystore credentials. So I mentioned you need a key to get to the key. So they all have their own access control mechanisms. You have to have a credential. Usually it's a password, and you have to present it in order to access the Keystore. DB2 is going to try and access the Keystore, so it needs this credential. I just finished telling you not to use PKCS12 Keystores. So to access one where it actually contains the master key, we just need access to the file, and that's all we need.
So we need it. Wait a minute. Now we need a key to get to the key to get to the key.
Not yet. Soon. So for that one, you don't need a key to get to the key. You just need access to the file itself. But when you're dealing with centralized key stores, we actually tell you that the best way to protect the credential is to create a Keystore file that contains the key. So now we're doing the key to key to key stuff. So you put it in a protected file that contains the credential, and then we access that file, we get the credential, and then we pass the Keystore and we get into the Keystore. So the challenge is the other choice is not to do that and just have your operators know it, and so that at 3 in the morning when DB2 needs to restart, they can wake up and type it in. And nothing ever goes wrong there. So
not at 3 o'clock in the morning.
No, yeah, we're all very functional at that time. The challenge here is how to best do this for your environment while keeping them secure. And there's there's some options that I'll talk a bit about. You can put it on the DB2 start command. You can pass it in. You could have it prompt. Both of these are either, if you put the first one in a script, your security people should take you outside, and I guess we don't shoot people anymore, but they should just take you outside and leave you there, because now that script has the password in it. So that's not a good habit. That's best done when a human being is typing it and immediately wipes out their history. The open Keystore, it will prompt you, and then it will mask the Keystore, so that's a safe way to do it. And then you can also use the file name. That's when you have direct interaction with DB2 Start. The other way is a stash file, where you tell DB2 there's this file, and you can go access it, and you don't have to actually type it on DB2 Start. You type DB2 Start, and it automatically goes to the stash file to look for it. So those are the sort of the mechanisms we try and provide to give you options in terms of how you handle your Keystore credentials. So how does encryption affect my disaster recovery strategy? So I mentioned, and I'll harp one more time, that you need to have the master key in order to access the data. The other thing is you also need to have the master key that's relevant to the time when that data was encrypted. So if you have transaction log files or backup images from 2 years ago, I'm now in the future, so 2 years ago, you need to have the access to the master key that was in use at that time, because that's the master key that they know about, and that's the master key they're going to ask for, or DB2 is going to ask for when it tries to access that data. So effectively, you need to keep your Keystore backups for as long as you keep your data. And we actually recommend at the bottom there, never delete your master keys, because something will go wrong. So it's better to just keep all the master keys, even though they're no longer being used by the current system, just keep them. So recovery of a backup and rolling through the logs will actually ask for the master key of the backup, and then it'll start rolling through the logs, the transaction logs. If the master key rotated halfway through there, it will be asking for master key 1 when it opens the backup, because that's what it was using. And then as it goes through the transaction logs, eventually one of the transaction logs will say, no, I'm using master key 2 to protect the EK. It says, oh, okay, let me go get master key 2. So it does go through the Keystore and get the different keys. Don't have a disaster recovery plan like the one I show here, although that's often the case, unfortunately.
Help.
All right, additional considerations. I mentioned when you add a new master key and you want to use it in the system, it's not automatically sent across to the standby at this time. It's sent across as soon as there's a new transaction. So if you're not using a shared Keystore, then you have to be a bit more careful with how you coordinate it. So you actually want to put the master key in the primary Keystore, and then go put it in the secondary Keystore and back it up, same rules as before you do the key rotation. That way they both have access to it and both have a backup in case something happens to their Keystore. So again, just keeping the Keystores in sync if you use multiple Keystores. That same picture would apply if you're using multiple Keystores in pure scale or in DPF. You need to keep them in sync. Oh, my favorite, encryption and compression. Unfortunately, many people find this out afterwards. So the basis of encryption is to take the data and just really randomize it and get rid of all patterns and strings. The basis of compression is go find those repeating patterns and compress them and save space. So they don't work together. There's a basic problem when you're trying to compress encrypted data, your compress rate is not going to be, well, it might be above 0, but in decimals. So if you rely on disk deduplication techniques right now to reduce your backups and transaction log size, encrypting them is going to eliminate and increase your disk space requirement. So that's a major impact for some customers.
That could be huge, because DB2 compression is awesome, often saving 50–60% of your disk space.
Well, DB2 compression is cool. It's when they're using file system or hardware disk deduplication techniques.
Oh, okay.
So they write the backup to a particular disk, and the disk has deduplication inside it. So to get the benefits of compression, you actually should use DB2 compression, because that data is compressed before it's encrypted. So
okay.
DB2 is working on compressed data, and so remember we're physically encrypting, decrypting we're encrypting and decrypting what's physically written to disk. So the data is compressed in DB2, and then the compressed data is written to disk, and that's what gets encrypted. So that's one way to reduce the the transaction log and the actual physical size of the database and the backup. The other way is you can call there is a combination log library provided that does compression and then does encryption as part of the backup support. Ember has a very good blog on this, and I recommend going to look at it. It certainly lays it all out, and she has a lot of practical experience in this. So rather than developer telling you to be wary about this, go read what one of your colleagues says.
Well, it's good that we got clarity on this. DB2 compression is good. Compression outside of DB2 is going to be impacted.
Correct.
We got it. And go read Ember's blog.
That's yeah. All right, the operational window. So as I mentioned, now we're doing backup and restore. They're doing physical I/O, and they're very intensive, and they have very little caching benefits. And so depending on how much overhead encryption hits them with, and again, that depends on your hardware acceleration, they could be hit badly, and it will affect their time. A couple things here to know. First of all, each backup gets its own unique data encryption key. So it's not using the same DEK as the database. It's got its own. Reason for that is it's now a separate physical copy. We want to make sure it's protected separately. And we're trying to minimize the spread of that data encryption key. This means that the backup and restore is actually going to, if it's reading from disk, it's going to decrypt from the database DEK and then re-encrypt or encrypt again using the backup DEK. So there is some extra overhead going on in here. And that's why hardware acceleration and, where possible, parallelism is critical. Right now, we allow a backup thread per table space. By the way, there's an RFE to allow parallelism within a table space, and I'm pushing hard for it for the reasons listed here. Please go vote for it. But basically, this is a place where if you can use parallelism, use it. Because it helps spread out the CPU, assuming you have the CPU available to handle multiple threads. Like each thread is going to need its own CPU, not fully, but just to allow it to not have serialization fights between the different parallel threads. It will increase CPU consumption. It's doing, in this case, encrypting twice. And if you're using compression as well, it's all software based, so it's going to increase. Now there are some enhancements. I think I can't remember, but there were some enhancements recently that some software compression will use hardware that's available. But the general rule of thumb is there's a lot going on here. A lot of it can impact your time and your size. So in this case, you need to experiment with your backups and restore times under an encrypted environment. That's the net of this, right? Because they may take longer, often significantly longer, and you need to be ready for that.
Okay.
All right. Well, that's all. So that was the gloom and doom pitch. But like I said, I'd rather people thought about this up front and planned for it rather than sort of come running in. They're in production, and that's when they find out that their 12 gig disk system won't contain the 120 gigs they're trying to write to it.
Right. All right.
So
let's remind people too, if they have any questions, use the GoToWebinar question tool there, and people can send questions in if you have any questions for Paul. Summary,
right,
Paul.
And this is the time where I say the purpose of the presentation is to spark a little bit of fear in you. Just, a little bit of fear and anxiety is good. It's not meant to make you panic and say, oh my God, but it's just meant to be aware, be conscious that there are some consequences, so plan, think ahead. In summary, we continue to enhance native encryption. I list some of the things here. I've mentioned some of them as we went along, but there have been changes. So if you put native encryption in place in GA or modification 1, take a look at some of the other things, and you're not on the modern versions, think about it. Finally, summary. So I don't think in the long run, none of us are going to have a choice. We're going to have to encrypt our data at rest. So the data on disk is going to become a fact of life because the risk, both financially from lawsuits and reputation, you just have to think about certain companies who sort of say, trust us with your data, and then they have a huge data leak because they weren't encrypting their data. It's huge. That risk is huge. So it's going to be mandated, and eventually everyone's going to be doing it. It doesn't come for free. No matter how you do it, it comes with a cost to your organization, both in performance, availability, and operational. And I've tried to list some of them in this presentation. As I said earlier, plan ahead. It'll make your life simpler, and try and avoid unpleasant surprises. And as long as you do your due diligence and you prepare and you experiment and you try it out, it doesn't have to be scary, because basically you understand consequences and you understand how it impacts your workload. And all that said, it's actually fairly easy to start and use, and it's very transparent. So go ahead, give it a try.
There you go.
That's all I have to say. Are there any questions on the?
Nobody's asked any questions yet, so that's good. Yes, it is. Let's see. Now we need to switch over to me again. Make presenter, show my screen, and here we go. It's time to ask another polling question or two. Let's ask people this question. We're putting DB2Night show replays on YouTube now. Have you subscribed to our channel yet? And would you please? This is just a quick question. Kind of emphasizing the point that we are now putting our replays on YouTube, which is cool because you can stream the replays on YouTube or you can still download them. So many ways to get your free DB2 education. Let this go here for another little bit. Going once.
I just learned the other.
Go ahead, sir.
I just learned the other day how to download YouTube.
Oh, you can download
so
YouTube.
I could find
videos.
YouTube. Yeah. It was, my wife needed something. So, sorry. Let you finish your poll.
Well, that's cool. You can download. I got to learn how to do that. Oh, and that reminds me, Paul, will you please send me a PDF of today's presentation that we could make available as a handout in the replay blog?
Sure. There's notes too as well, so I'll send you the notes version.
Send me the notes version. Excellent. Our audience will be really happy with that. Closing the poll, sharing the results. 33% have already subscribed, 60% not yet, but we'll check it out. That's great. 13% said YouTube is prohibited at work. Well, that's why you watch on the weekends when you're not at work. 7% was YouTube. You guys are funny. And our last question, did you learn anything today? We always ask this question at the end of the show. Did you learn anything today? It's a great presentation, full of your performance, availability, and operational considerations. You've prevented people, hopefully, from walking into this blind, right? So now they know what they need to know. Going once, going twice, closing the poll, sharing the results. How about that, Paul? 100% of our good-looking audience learned something from you today.
They are particularly good-looking, aren't they?
That's the best-looking audience we've ever had. All right, so we need to get you to watch those replays. You can find them on db2nightshow.com. We'll have a survey when this show ends. When you exit, there's a little participant survey. We appreciate your participation. That's how you win the Amazon gift cards that we give away. Thank you very much to our attendees for joining us today, and most of all, thank you, Paul, for being our guest. I know we planned this for quite some time to get you back on the show, and I'm glad you're here. And so is our audience.
Thank you for the opportunity. I appreciate it.
You are very welcome. We'll get you back another time. Will you be at iDoug in Charlotte, North Carolina?
That is the plan, yes.
Oh, awesome. We'll get to see you there and share an adult beverage.
Excellent.
All right. Today's show was sponsored by DBI Software, offering smarter tools for smarter people. DBI is your trusted partner for breakthrough DB2 performance solutions that deliver invaluable results for organizations having the most demanding requirements and discriminating preferences. And noteworthy, Paul just taught us if you're going to do this encryption, then it's important to look at tuning all over again, because you need to pay attention to those operations and things that have heavy I/O. So it's a good time to pay attention to tuning. And that's our app. That's time to wish everyone a happy, wonderful, and safe weekend. Paul, all the best to you, sir.
You too, Scott. See you at iDoug.
All right, I'll watch my email for your PDF.
Right, on its way.
See you at iDoug, and hopefully see you in the next show if you want to join as an attendee and learn about iDoug.
Oh, I do. I download many of them.
All right. See you soon. Bye-bye.
Bye.